Hello, grade 12. Today we're going to be looking at question 6 of the June examination 2021 done at the Northern Cape province. We already marked or have the videos of questions 2, 3, 4, and 5. So we're going to be looking at question 6, and this is about organic chemistry, okay? So let's look at the question quickly. The question said, the table below show the vapor pressure values of the organic compounds A to E. The letters X, Y, and Z represent vapor pressure values for compounds A to C. You can see here in the right hand side you have a vapor pressure in the table, and they give you the vapor pressure of certain compounds. Okay? However, we don't have the vapor pressures for compounds A, B, and C. Right? So we have pentane, we have methyl butane, we have 2,2 dimethyl propane, we have ethanol, and we have methanoic acid. Okay. Now, question 6.1 state define the term chain isomer. So before we go to stay chain isomer, let's look at small summary on isomer. Okay, so let's look quickly what are isomers, and we done structural isomers. Okay, now in general, what are structural isomers? Right? So what are structural isomers? Structural isomers are compounds with the same molecular formula but different structure. Right? That is a structural isomer. Note, I am not answering the question yet. I just doing a summary in case somebody struggled with this part of the work. So, structural isomers are compound with the same molecular formula but different structural formula. Now, we have 3 different types of structural isomer. So, structural isomer can be divided in 3 groups. First one is chain isomer. The second one is the positional isomer. And the third one is the functional isomer. So those are the 3 different types of isomer we're dealing with. All of them belong to the group called structural isomers. Okay, so let's quickly have a look to each of them by definition. We're not going to explain in details, but we're going to be looking in definition. Now, what are chain isomer? They are compounds with the same molecular formula but different type of chain. Right? Now, something important to have here in mind when we're dealing with this one. Those chain isomers are always going to be compound from the same homologous series. So chain isomers are always going to be from the same homologous series. A chain isomer of an alkane must be another alkane. A chain isomer of an alcohol must be another alcohol. Alright? Now, the second one, the positional isomer. What are the positional isomer? The positional isomer are compounds with the same molecular formula Let me just fix this one. Same molecular formula, but different position of the functional group. So the position of the functional group is going to be different here. Position of the functional group is different. All right, still same molecular formula. Remember, the positional isomer still belongs to the group called structural isomer. Now, important to know, once more, positional isomer must always be from the same homologous series. From the same homologous series. For example, a positional isomer of an alcohol must be another alcohol. It cannot be an alkane or an alkene. A positional isomer of an alkene must be another alkene. All right, and we're going to the last type of structural isomer, which is the functional isomer. They have the same molecular formula, but different functional group. Functional group. Right? Now, here, obvious they cannot be, if they have different functional groups, it means they are going to be from different homologous series. Now, we have only two combinations here. We have ketones, and aldehydes, that is one possible combination, which means if you have a ketone, a functional isomer of a ketone may be an aldehyde. It cannot be any other homologous series. So, or vice versa, a functional isomer of an aldehyde might be a ketone, or is going to be a ketone. It cannot be any other homologous series. And the other combination is going to be the carboxylic acid and esters. Same as ketones and aldehyde. This means that a functional group, a functional isomer, of a carboxylic acid is going to be an ester, and the other way around. A functional isomer of an ester is going to be a carboxylic acid. Now, going back to the question of the unit examination asks for chain isomer. Define chain isomer, and this one is already been defined. This is the answer, and if you define correct, you get the 2 marks. This question is for 2 marks. I'm going to write the total here at the bottom. Right? 2 marks for that one. Define a chain isomer, and let's just go back about this one. The chain isomers are compounds from the same molecular formula, but different type of chain. However, this is a small summary about a structural isomer. Go through it. It's always going to be asked in the question papers. All right. So let's go to, this is 6.1. Let's go to 6.2. Please note, you don't have to do all this one to answer the question. All right. To answer the question will only be about chain isomer. That is the answer. Chain isomer with the definition. All right. Now 6.2. Question 6.2. They said, write down the structural formula of a functional group of a compound E. Now, what is compound E? We're talking about compound E. Propanoic acid. Oic acid is used for carboxylic acid. So compound E is carboxylic, or is a carboxylic acid. Carboxylic acid. We're looking for a functional group of the carboxylic acid in a structural formula. Now, note the functional group of the carboxylic acid used in a structural formula will be carbon, double bond oxygen, single bond oxygen, hydrogen. However, remember, carbon must have 4 bonds. Here we have 3. So there must be another bond for carbon, mustn't be touching the carbon, there is the other bond for carbon. This is the answer. This one here is the functional group for carboxylic acid in a structural formula. In a structural formula, which is the question. Okay? That is the answer. If you do that, then you get the mark for that question. Let's go back to the marking. You can see it's 1 mark for that one. Now, note the following, and this is very, very important. If you forget to write down this bond here, you don't get the mark because it is wrong. If you instead write the complete structural formula for the compound, which is methanoic acid, then it's also wrong. I'm going to draw the structural formula of the complete compound, but it's not the question, all right? So carbon, double bond oxygen, oxygen, hydrogen, that is the functional group, and is meth, and meth is for 1. Note, what I'm doing is no answering the question, I just to recall it. So this is 1 hydrogen. This here is methanoic acid. This is not the question, so you don't get mark if you do that. All right, the mark is allocated for the functional group. Right, now let's go to question 6.3. Now 6.3 is a little bit of a long. 6.3 is a little bit long, and you don't have to write everything I do. However, I prefer to practice like this because every time or most of the time it's going to be in that way. This is the values x, y, and z are given, not in order, in the table below. So you have the values for x, y, and z on the table. All right, you have 53,3, 14,6, and 77. Choose the vapor pressure of compound B from the table above. Fully explain your answer. So now, what would I do, and what would I suggest you? Okay, so I'll say first, compounds A, B, and C, all of them, if you look here, all of them are going to be alkanes. So that is the first thing I'll do. I'll identify the homologous series. So I'm going to write compounds A, B, and C are alkanes. All right, that to me is important to know. Why? Because alkane have, so I'm going to write alkane with London forces. That means that the type of intermolecular forces between the molecules of each of those compounds are London forces. All right, now what else will I say? I'm coming here and I look to, if all of them are alkane, what is different? Now, what is different with these 3 alkane? Those 3 alkane have they decrease in terms of surface area. So, for example, the first one is pentane. Pentane will be 1, 2, 3, 4, and 5. Pent is 5. So this is pentane. Let's quickly have a look to each of them so you know what is different between them. This is pentane. Let's add all the hydrogen. Make sure every carbon have 4 bonds. This is compound A. Now compound B is going to be 2-methylbutane. But is for 4, so we have 1, 2. Let me just move it a little bit more to the right. We have 1, 2, 3, and 4, and then 2-methyl. In carbon 2, you have a methyl, which is CH3. There we go, and then the rest are just the hydrogens, right? The hydrogen. This is compound B. And now compound C, sorry, let's fix this ugly B, so it's compound B. And compound C, there you go, is 2,2 dimethyl propane. 2,2 dimethyl propane. So now we have 3 carbons, 1, 2, and 3 is prop, and in the carbon 2 we have 2 methyls. 1 methyl and another methyl. Right? So here we are with the 3 compounds. This is compound C. Now, what is different in each of them of the compounds? All of them are alkane, but what makes them different? Okay, what makes them different is as you move from A to B to C, they become more spherical. Therefore, they have more branches and the surface area is smaller. Right? So I'm going to write that one in that specific way. So I'm going to write the following. Compound A has a greater surface area than compound B. And B has greater surface area than compound C. So let's go back. First, I identify what type of a compounds are they homologous series. Here you can see I said all of them are alkanes. Now, second, I identify the type of intermolecular forces. Here, because all of them are alkane, all of them will have the same intermolecular forces, which is London forces. Then I am going to look what is different. If they are from the same homologous series, I'm going to find out to determine what is different between them. Here you can see that is the surface area. Surface area is what is different in each of the compound. So what did I say? The compound A has a greater surface area than compound B, and B a greater surface area than compound C. They will be the first mark for comparing the surface area. You can also say compound A is longer than compound B, compound C is more spherical than B and A, and so on. Alright, I prefer to speak about surface area. Now, what is the issue? What the surface area, what is the influence of surface area on the intermolecular forces? Well, if you have more surface area, this one is longer, then you will have more site or more spaces for London forces, which is the type of intermolecular forces here. So I will say now, there are more spaces or more site for London forces in compound A than B, and in B than C. Alright, so I will come here and I'll speak about now spaces in the London forces. Who has more spaces? Well, they have the one that have a greater surface area. Now, what happens when there is more spaces for the London forces? The intermolecular forces in A are going to be therefore stronger. So, and I'm going to write intermolecular forces. Alright? Are stronger in A than B, and in B stronger than C. So now I am comparing the strength of the intermolecular forces, and there is the second mark. Now you would say, why are you speaking so much and there's only 2 marks? Okay, in this question there's only 2 marks, but sometimes in other questions they give mark for identifying the homology series. Sometimes they give marks to identify the type of intermolecular forces, so you never know where are the marks going to be allocated, so better to be safe. Okay, so there is a strong intermolecular forces in A than B and B than C. Now there is the second part you have to write here now, which is in terms of energy. The stronger the intermolecular forces, the greater the energy is needed to break those intermolecular forces. So I'm going to write now more energy is needed. More energy is needed to break. To break the. To break. Let's fix these words here. To break. So more energy is needed to break the intermolecular forces, and I want to emphasize, be careful. You cannot try to break the bonds. We are not talking about bonding here. We're speaking about intermolecular forces, so be careful. More energy is needed to break the intermolecular forces, no bonding. Okay? In A than B, and in B than C. Alright, and there is the last mark allocation for this part of the question. Remember, the question asked to identify. We're still going to identify right now. And then we're going to the last small part of this explanation. If there is more, or you need more energy to break the intermolecular forces in A, therefore A have a higher boiling point than B and B than C. So higher. Boiling point in A than B, and in B than C. Now you will ask, you might ask, why is he speaking about boiling point? The question asks about vapor pressure. Okay, so now what is the importance of speaking about boiling point? The relationship between boiling point and vapor pressure, which I'm going to write here, and I'm going to write it with this other color. The higher the boiling point, I'm going to use VP for boiling point, the lower the vapor pressure. The higher the boiling point, the lower the vapor pressure. So if you go there to the question, let's quickly go back to the question. We have these 3 numbers. This one have the highest boiling point. A have the highest boiling point, the lowest vapor pressure. The second higher boiling point, the second lowest vapor pressure. So B is right in the center between A and C in terms of boiling point and vapor pressure. Be careful, because it's not always going to be in the center. It depends on the structure, it depends on the intermolecular forces, as explained in the question. So from which one will be the number? It cannot be the higher. 77 will belong to C. This will be 77. 14,6 is the lowest one. It will belong to A. That will be 14,6, and then the answer is 53,3. That is the answer. The question said, what is the vapor pressure, and explain. So it will be, the final answer will be 53,3 kilopascal. And that is the final mark for this question. There are 4 marks there in total. One for identify the number and the other one for the explanation. I think this is the best way to explain because generally it's always the same way, the same steps. All right, now 6.4 and last one of this question, question 6.4. Question 6.4 asks, and this one already answered, you'll see now, which one of the compound D or E has the highest boiling point? We already answered this one. So the highest boiling point will be, okay, no, we did not answer. We're now speaking about D and E. So let's go back about D and E. And let's use the same steps, even though they do not ask to explain. But it will be very good for us to explain. So what we did first, we first identify what are they. All right. So here, what compound is D? Is ending in ol, is an alcohol, is ethanol, and the second one is methanoic acid, is a carboxylic acid. So let's start by, this is not part of the question. The question only said identify. Okay, but let's explain quickly. All right. Compound A is an alcohol. Compound A is an alcohol. Okay, compound A is an alcohol. So, compound A is an alcohol. What type of intermolecular forces has an alcohol? It has hydrogen bond. Hydrogen bond, right? Let's go to compound A. No, it's not compound A. Oh, yeah. Sorry about this one. It's not compound A, it's compound D and E. So compound D is an alcohol. Compound D is an alcohol. Compound E is a carboxylic acid. It's a carboxylic acid. Carboxylic acid also has hydrogen bond. Now, what will be the difference between those two compounds? If both of them have hydrogen bond, then what will be the difference in terms of intermolecular forces, boiling point, etc.? Okay, here you have only one side for hydrogen bond. The alcohol have only one side for hydrogen bond. For hydrogen bond, while the carboxylic acid has two sides for hydrogen bond. Do you understand? So here in question, in compound D, you have only one hydrogen bond, or you can form only one, while in a carboxylic acid or compound E, you can form two hydrogen bonds. So now we come into the strength of the intermolecular forces. The intermolecular forces are stronger in compound E than D. There we go. Now it's coming to energy. More energy is needed to break the intermolecular forces in compound E than D. And then you come in to boiling point. Higher boiling point in compound E than D. That is the answer. However, I use this one to explain just for you to recall. You don't have to explain. Why? Because in the table you have already the vapor pressure. So the lower the vapor pressure, the higher the boiling point. Alright, so you don't have to explain all this one, but sometimes they ask you to explain using energy and type of intermolecular forces. So the answer is E. That is the answer. You will get the mark for writing E, and then that will be the final mark, which is 1 mark. The total for this question is 8 marks. Thank you very much. I hope it helped. Again, I always recommend you to answer the question before you watch the video. Okay? Thank you very much. Next time we'll go with question 7, which is rate of reaction. Thank you.